Good day, everybody. This is Chris back again with the Ancient Scholar, and today we're going to be talking about a very fairly diverse group of substances that fall into the same category, and that is they cause similar, somewhat similar at least, signs and symptoms when used and or abused, and that we collectively call this group of substances the psychedelics or the hallucinogenics, even though there is certainly debate as to what it means to cause hallucinations and what goes on there. But basically, these are substances that cause some sort of alteration in sensorium and alter, in certain ways, alter the ability for a person to alter the way in which they perceive reality. Um, and the specific signs and symptoms can vary from person to person, can vary from substance to substance, and unfortunately, it's such a complicated topic that I only be able to really be very broad, um, and very broad and very general in the way that I describe these agents. And there's so many of them that I'm not really going to be able to give you a demonstration of the molecular structure of every agent within the hallucinogenic classification of drugs, but we can go ahead and talk about the major categories, and then I will go ahead and in subsequent videos I will show you specific important examples of prototypical agents that belong in each category. So let's go ahead and just start. So basically when we talk about hallucinogens or the psychedelic agents, there are basically four categories of psychedelic agents. There are what we call the serotonergic agents, the norepinephrinergic agents, the anticholinergic agents, and then the agents that don't fall into any of the other three, and we just can call them miscellaneous or other agents. So let's talk about the serotonergic agents. Two of the four categories of agents are much more similar, and then the other two are are a bit dissimilar, at least when looking at the chemical structure. So the first two that I'm going to talk about share some fundamental chemical similarities, if you will. The first one I'm going to talk about, the first category, the serotonergic agents. These are agents that mimic the action of serotonin, or they enhance the action of serotonin in some cases. This is an example of the serotonin molecule. This is a monoamine, and just like all of your monoamines, serotonin is derived from the amino acid tryptamine, and you can see that with this aromatic ring in this monoamine structure here, as they have this amine chain that comes off of the serotonin. The other name for serotonin is 5-hydroxytryptamine, because you basically have a tryptamine molecule, and you make some very small modifications to that. Of noteworthiness is it kind of goes into the name, where you have your 5 carbon here, and you have on the aromatic ring you have a 5 carbon, and you have a hydroxyl group that comes off of that, hence the name 5-hydroxy, and then you basically have your tryptamine molecule here. Serotonin acts upon serotonin receptors, of which there are many types of serotonin receptors. There are the three major types that we look at in terms of psychedelics are the 5-HT1A, the 5-HT1C, and the 5-HT2 serotonergic receptors. And in terms of some of the more profound hallucinogens that cause very profound hallucinations, it looks like activation of the 5-HT2 receptor plays a very important role in those types of that type of activity. So what types of agents fall into the the category, the classification of serotonergic psychedelic agents? Well, the big ones, the really big, commonly used, popular agents fall into the serotonergic category, and they all they all have a very somewhat similar structure to serotonin, 5-hydroxytryptamine. And the agents that fall into this, some of the major agents include LSD, include psilocybin, magic mushrooms, if you will, include DMT. So you have 5-hydroxytryptamine here. DMT is dimethyltryptamine. So as you might guess, I just modify serotonin a little bit and add a couple of methyl groups to it, and I now have DMT, is a very potent serotonergic psychedelic agent. And I'll go ahead and show you examples of molecules in subsequent videos. This is more of an overview video. All right, so all of these agents tend to have their strongest activity on serotonergic receptors. I should note that some agents like LSD seem to block some of the serotonergic receptors. For example, I believe LSD actually blocks or antagonizes the 5-HT1A receptor, but is a strong agonist to the 5-HT2 receptor. So there's some really complicated neurophysiology going on. Okay, so I'm going to put the serotonin off to the side here, and let's move on to our next group of molecules, or next group of psychedelics, and these are the norepinephrine like, or norepinephrinergic. So here I have a molecule of norepinephrine, and you can see that there is a structural, because it is a monoamine and it is a tryptamine based, just like serotonin, and like epinephrine, like norepinephrine, like dopamine. They all share this very similar chemical characteristics in that you have a benzene ring here, you have your monoamine side chain here, you've got hydroxyl groups coming off different carbons. This has 2 hydroxyl groups here, and that is actually a very very characteristic, a structural characteristic of sympathomimetics like norepinephrine and albuterol, those kinds of agents that we sometimes use to attach to alpha and beta receptors in the peripheral nervous system. This structure, this benzene ring, the 2 hydroxyl groups coming off the benzene ring, and then the amine side chain, is highly characteristic of those types. Adrenaline or epinephrine falls into that category as well. But in this case, when we talk about the norepinephrinergic agents, we are talking about primarily about the central nervous system effects of these agents, and these agents seem to, when we talk about their psychedelic properties at least, they seem to have a very important role in the dopaminergic system and the central nervous system, increasing levels of dopamine and pleasure reward pathways and other pathways that can cause other signs and symptoms that are consistent with the psychedelic experience. So what kinds of agents fall into the norepinephrinergic? Well, mescaline, for example. Mescaline is structurally similar to this. MDMA, or ecstasy, is structurally similar to this. Let's see, MDPV is another one. And then COT, and I believe that COT, or CAT, however people want to enunciate that, is a cathinone. All of which have a very similar structure to norepinephrine. Really important as far as the neurotransmitter of importance also becomes dopamine as well, dopaminergic effects. So there you have your norepinephrine-like molecules, and in some sense, some of these molecules really chemically they resemble amphetamines much more than the serotonergic agents, which really do resemble serotonin. Particularly things like MDMA or ecstasy have a highly characteristic amphetamine-like structure to them, even though they do cause they can cause psychedelic effects, and we'll talk about those agents in more detail. Okay, the next group of agents are the acetylcholine-like agents, or what I'll call, they're not really like acetylcholine. They have somewhat of a similar structure to acetylcholine, but really what they are is they are anticholinergics. And these include things like atropine, scopolamine, and hyoscamine. So what I have here, let's see if I can show you guys. I have a molecule of atropine. Atropine is the prototypical anticholinergic agent. Atropine it does come. It can be found in nature. It can be found in the belladonna alkaloid, deadly nightshade. It was used a long time ago. Women would put drops of this in their eyes, and it would cause pupillary dilation. And in fact, this belladonna means like beautiful woman, and that was considered a very attractive characteristic in women to have these big dilated eyes. How the times have changed. Although if you look at like some of the cartoons out there, they still kind of have those big dilated looking eyes. So I suppose there's still some sort of cultural zeitgeist that revolves around that. But be that as it may, here I have a molecule of atropine. And actually, atropine, when I say atropine, I want to be very, very clear what I mean. Atropine is a racemic mixture of two molecules, two isomers or two enantiomers. So when I say atropine, atropine actually has two forms. It has a D and an L form, and I have when I say atropine, I mean that I have a racemic mixture that's a 50-50 mix of this is an optically active isomer. So if I let's see if it's kind of hard to do here, but if I kind of flip this around a little bit here, this hydroxyl group, see it's kind of how it's facing towards you guys now, and then I can have it facing away like so, and I have these two isomers, and it's the same molecule. It's just kind of you have a dextrorotary and a levorotary, kind of a mirror image, if you will, of that. So atropine, okay, atropine is a racemic mixture of both the DNL form, and then hyoscamine or hyoscymine is the levorotary form of atropine. So if I were to just take the racemic mixture of atropine, and I were able to just pull out the levorotary form of that levorotary form would be hyoscamine or hyoscymine. So it's basically atropine. Okay, it's just an enantiomer of atropine. So atropine is a racemic. Hyoscamine is the L form of atropine concentrated, and then scopolamine. Scopolamine, if I make just a tiny modification, and that modification occurs down here. And I should say that all these yellows here, I ran out of black carbons, because normally black is carbon if you watch my other videos. So I just had to substitute another one because I ran out of carbons making all these molecules. Anything that's yellow is a carbon, okay? Red's still oxygen, white is still hydrogen, and blue is still nitrogen. And because I'm limited on hydrogens, I only put hydrogen where it's relevant. But you'd have to assume, and we do this in organic chemistry, wherever you see these little holes here, wherever you don't have an octet met, you just have to kind of use your imagination. Go, oh yeah, there would be hydrogen there. We do that a lot in organic chemistry. We don't really draw every hydrogen, and I like to put them in for the sake of completion, but I just didn't have enough in my molecular sets today, so. You just kind of have to use your imagination that you know that there would be hydrogens coming off of some of these carbons. So anyway, to go from atropine to scopolamine, I go down here, and let's see if I can show you guys this little ring-like structure here. I break this bond here, and then these would bond. Let's see if I can show you. So I break this bond, and then these would bond to an oxygen down here. And you know what? Maybe I can just do that just to show you. I mean, what the heck? Nothing wrong with just, I mean, since I have the ability to do that, we might as well here. So if I come down here, and that goes to oxygen, and then that goes to oxygen, like so. All right. So now, with just that simple, rather simple modification, I have turned atropine into scopolamine. So these are the anticholinergics. These antagonize primarily they antagonize the parasympathetic nervous system, but when overdosed, these agents can cause significant hallucinogenic effects in addition to the pronounced anticholinergic effects such as drying out of the mucous membranes, dilation of the pupils, increased heart rate, increased blood pressure, so on and so forth. These can cause psychedelic signs and symptoms. Things like Jimson weed, deadly nightshade, some natural plants contain these alkaloids, and so these are a bit different structurally than the serotonergic and the norepinephrinergic agents that we've talked about earlier. Okay. And then the last category, and I don't actually have a molecular model because they just kind of fall into the other. There are others that they don't share chemical similarities to the other agents. They actually have several different rings. Those include things like PCP and ketamine, and we'll talk about those in subsequent videos. Well, anyway, so this is just an overview of the major classifications of psychedelics: the serotonergic agents, the norepinephrinergic agents, the anticholinergic agents, and the miscellaneous agents. You have 4 categories, have lots of different agents in those categories, and I'll be making subsequent videos that will focus on those of selected agents from those categories. Okay guys, as always, thanks for hanging in there.